Start? Oh, that's great. Welcome everybody to our October 2024 fact meeting. We'll be getting started shortly with our topic for today, 19th century astronomy. I think most people know what we're about. We advocate science and reason in a society that seems to keep getting more and more in need of more of that kind of thing. There's a lot of things that we do, including a big web presence, giving awards for critical thinking to student science fair organizations. We've had picnics, expeditions, in-person meetings. For now, we don't have in-person meetings. If there's anyone open to helping us make that happen again, or possibly joining the council to help make up for a lot of us aging out, that would be great. Feel free to contact Deriva or me about how you could possibly help. Our biggest thing that we do is during the school year on the third Saturday of the month at 2 p.m. having these lectures. The only next one scheduled is, you can put this on your calendar now, for November 16th. The topic is Floater Toolkit, a life preserver for staying afloat in a sea of misinformation. And this will be a new speaker, Melanie Tracek King, a big time supporter of skepticism and promoter of critical thinking, giving a good overview of a lot of our fundamental values. So for today, our speaker that you heard a little bit talking about some of his last great lectures is Robert D. Hicks. He's been a scholar of history of science and medicine. He's most noted from what I've seen for having been a director for a long time of the freaky Philadelphia Mutter Museum and Historical Medical Library. He's been a chair of Medicine College of Physicians of Philadelphia, done all kinds of stuff to help people get a lot out of the museum experience. And he's had at least one book on my favorite lecture from him about Civil War medicine. So if you're here in person, this would be the time that you please join me and welcome, clappy, clap, 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 for our speaker of today, Robert Hicks. Take it away, Robert, and thank you for being here.
Well, thank you very much for that introduction. I appreciate it very much. At this point, we might want to shift to the PowerPoint screen.
Oh, and one other thing for Q&A, go ahead and just type your messages in the box, and then if Robert doesn't hit him on the fly, we'll have Q&A time at the end that Deriva will moderate. So
yes.
Just that is for questions along the way, just to not interrupt the flow.
Yeah, so please place everything in the chat, and if you would please type Q before the question, that would be very helpful. I will keep them. I will speak them out at the end to not interrupt Robert's talk. Thank you.
Okay, back to me, I guess. All right, we have the PowerPoint on the screen, yes, right now?
No.
We don't. Okay, I thought, Wes, on your end, you were going to switch it.
I can take it down, but I can't put it back up. You're going to have to share your screen again.
Okay, let me do it again.
There we go.
Okay, very good.
You probably want to there. Very good.
There we are. All right. Before I go a little further, I have a special thanks to make to FACT for a very nice, generous donation to the Doty Research Institute. I'm on the board. Anna Doty was my longtime colleague. She was the curator at the Mutter Museum and now has an independent institute to further research into particularly medical collections, both anatomical, even artifactual, that can yield information of scientific value. We demonstrated that that was possible through with smallpox tools and also with cholera specimens. And the Mutter Museum provides the earliest securely dated samples of smallpox vaccine in the world now, and also earliest securely dated cholera sample from a strain of cholera that's no longer active in the world. So that kind of research is going to continue under Anna, as well as a lot of educational work in promoting science. So as a board member, I wanted to thank you all for having the foresight to invest in this forthcoming enterprise. All right, back to the topic, popular astronomy. I hope this is going to be a pleasant trip for everybody today. There's no political debate here. There's simply speculation about the cosmos. So I hope you enjoy it. It's something we don't think about. We, of course, have astronomy in the news a great deal now. And sometimes the news is pretty abstruse when we talk about dark matter and dark energy and the origin of the universe, and it goes beyond everybody's daily experience, and it gets a little difficult. But if we look back in the 19th century, which is just a hop, skip, and a jump back, we find a lot of the same questions people had, but we find a higher level of science literacy and a higher level of astronomy literacy. And before I leave this particular image, this is an 1851 image. I've got it framed on my wall. I love to look at it because all these kids lined up with an instructor with a nice lawn wand that could be used to point out things, but also hit a kid who's not paying attention. But you see this diagram of the cosmos. The oblongs, not quite circles, but the oblong tracks that are leading in and out of the solar system are comets. But if you look very closely, it's a bit of history of science here, because the orbit of Uranus and the orbit of Neptune, you don't see a Neptune, you don't see a Uranus. It's planet Herschel instead of Uranus, and planet Leverrier for Neptune. So if you're wondering why that is, you will have to go to the internet to find out. All right, so get this. I have already been introduced, a long time, almost 12 years at the Mutter Museum, and there's a new regime there now. This has been in the press a lot of controversy about what's going on there, and it's all beyond me. But to establish my astronomy bona fides, I have been a long-time amateur astronomer. I have an astronomy observatory on the roof of my house. I've had some really good luck in the past with astronomy, and 50 years ago plus, I had access, I had the keys to this observatory in Quito, Ecuador, which is a separate story, but I had the use of this very important historic refracting telescope, which is effectively located almost right on the equator. So I've been with this topic for a long time, and with its history for a long time, I was able to bring it back into my own academic work when I went to the UK for a PhD in maritime history, particularly looking at the history of navigation, celestial navigation in particular. It's a good image to start with James Webb Space Telescope before launching into this, because the kinds of questions that we are posing for the space telescope, for the Webb Space Telescope to answer concerning the age and origin of the universe and everything that evolves out of that, including ourselves. These are very similar questions that were being asked in the 19th century by audiences in very, very, very popular lectures that were very widely attended. There's a lot of interest in astronomy for reasons I'll go into that are a little bit not there these days in our own society. But I want to start briefly 2,000 years ago with these images. Now, both of these images here, these are the same kind of instrument built 2 centuries apart, based on a very, very ancient model that goes back to classical times. This is the model of the universe that was familiar to people for centuries. And it's actually a computational model as well as a demonstration model. The Earth is represented at the center as a stationary object in space. And all of these convoluted circles around it represent the celestial sphere. People were imagining all the stars, the planets, and so on in a shell around the Earth, actually concentric shells, and they moved in particular ways. So over time, of course, people observe where sun, moon, rise, set, the periods and cycles of both the stars, the planets through the seasons, and also the strange planetary motions that from an Earth perspective look very convoluted and strange and irrational. But the basic reference points are all here. They're extensions of the Earth. There's a celestial equator, an extension of the Earth's. there are celestial north and south poles, extension of the Earth. And the path, the apparent path of the sun, moon, and planets occupies the ecliptic, or to most people, the constellations of the zodiac. They constitute the ecliptic. So this was a model that was solidified intellectually thousands of years ago, and becomes by the Middle Ages and the Renaissance one of the key sciences taught in universities. So basic astronomy was an essential part of a university curriculum in the Middle Ages that was known as the quadrivium, one of the 4 key subjects to be taught. And here you see all those reference circles in a illustration from a 15th century book. This treatise on the sphere, 15th century, is probably the single most influential astronomy text ever written, translated into multiple languages, and it was in print for centuries because it has the basics, and the basics haven't changed. And even today, regardless of where our sun is moving in space, regardless of where we are in the galaxy, for navigational purposes, the model you just saw with a stationary Earth is still the practical model for navigation purposes. You don't need to know that the Earth is moving through space. All you need to know is that's your datum, and you work out navigation with a celestial sphere. We know all the stars are different distances, but for charting purposes, for navigational purposes, that don't make a darn bit of difference. So we get to beautiful, beautiful versions of this instrument. If you collapse that 3-dimensional object into 2 dimensions, you get this. This is a flattened armillary sphere. And it's called an astrolabe. And this is a particularly pretty instrument. It was considered the jewel of mathematics 500 years ago. And everything that you saw, those reference circles, are all embodied in this tool. The other side, you have, on the left-hand side, there's an alidade that goes up and down and sideways, so that you can actually use sighting vanes on it to get the height of the sun or a particular star as a way to kick off the computations you want to make with this instrument. And what you see on the right is one of a plate that is inserted in this for a specific latitude. These kits, astrolabes were kits. They had multiple inserts like this so that you could get your latitude in the plate before you make computations by swiveling this alidade or a rule on the other side or a star map on the other side that's over this. And this is sort of a fascinating lecture and a classroom project in its own right. And you can still buy people that make these today, but not to this degree of artistry. I bring this all up because today we have the latest version, which is called the planisphere. Now, if you happen to go to Ebenezer Maxwell Mansion over in the Chestnut Hill area, and it's the only Victorian House museum in Philadelphia, and I think it's worth a treat to go there, but in one of the rooms where they have children's toys, they also have this on a chair, and it's a planisphere, and it's a rare survival of a large cardboard instrument that was sold for popular purposes. It allows you to orient yourself to the night sky by moving the blue field. It's a revolving disc or rotating disc. And it gives you all kinds of instructions on how you can make all kinds of determinations and predictions with this, particularly determine when stars are going to rise and set. It allows you to make some computations even with solar and lunar movement. And this is sold for popular audiences. It's not an observatory astronomy tool. And this is today's version. We've dropped the word planisphere. It's called a star wheel or star guide, and they're available at science museums. You can get them online. They're everywhere. This is the same thing. So the pedigree I've just shown you from that instrument from hundreds of years ago is carried through to this very tool, and cheaply available. It doesn't do all the things that the astrolabe could do, but it does a fair number of things for those that have the patience to learn the sky. Of course, you need a bit of a dark sky to do this, but nevertheless, some of you listening may actually have used these or possess them. So looking at the one that's at Ebenezer Maxwell, I've got up on the top left exactly those same reference circles you saw in the armillary sphere and the astrolabe. And I wanted to show this to point out that there is a pedigree for this kind of popular presentation of astronomy for people to learn enough to go out and identify stars and constellations and even make a few predictions when things are going to be available to see in the sky, when they're not going to be available. The one that's in Ebenezer Maxwell is far more sophisticated than any that are commercially available today. and it presumes a higher level of reading skill as well as some scientific background. But it shows you, carried into the 19th century, what we have is this kind of instruction being conveyed in classrooms. Astronomy is taught widely in schools in early America, and it's considered also a science on the move. It's a science that yields future discoveries, because in the past decade, 20 years, 50 years, 100 years before the mid-19th century, much has been discovered in astronomy, including a couple of planets. So the United States steps forward and decides to place its foot in scientific astronomy by constructing the U.S. Naval Observatory in the early 1840s. Now, this was a time when astronomy was necessary for wayfinding and for time measurement particularly, and it was necessary in an expanding country with the railroads and the necessity to create time zones to have an observatory that could handle all the data gathering and be the datum, be the benchmark for all of this information. Up till now, we were just importing it from Europe. Books on astronomy came from Europe. Any telescopes that were being installed in the United States were manufactured in Europe. But by the mid-40s, 1840s to 1850s and on, America takes the place of all that, both in instrument making and also the publication of astronomical books. Interesting side note on this, you will not be surprised to know that there was a fair amount of dissension in Congress about the establishment of a U.S. Naval Observatory, about investing in federal funds to do something like this. There were some people in Congress that said, well, wait a minute, this is a violation of states' rights. This isn't something the federal government should be doing. And besides, is it really all that important for the government to do this kind of work? Well, in the end, the government said yes and established, and the U.S. Naval Observatory is a functioning place today. I spent 2 summers in college there as an intern. I have the picture of the American Philosophical Society here because concurrent with this, the Lyceum, borrowed from Europe, a sort of philosophical chat group, became popular as a thing to do, to share ideas. And the Lyceum would start to show up in multiple cities in the United States, even small ones that were growing, where there was a hunger for people to share current events, but also what's happening in other fields, particularly what we are calling science now. Science now didn't quite have the same meaning as its use in the 19th century. And the U.S. Naval Observatory establishes a 26-inch telescope, concurrent with one in Cambridge, Massachusetts at Harvard University. So in those initial decades, from the 1840s to the 1860s, relatively few telescopes existed. Some private observatories existed. And that's yours truly at the eyepiece of both of those instruments, by the way. The 26-inch there, the Naval Observatory, was used also to discover the moons of Mars in the 1870s, which was not a small feat when you consider that the moons have diameters of only 5 and 10 miles respectively, and they're very close to the planet itself, so it's very, very hard to see them. Nevertheless, they were seen. So by the 1860s and 70s, multiple observatories are showing up throughout the United States. Universities are recognizing that it's a big boon for fundraising to have an astronomical observatory, and interest is growing in the subject. Now, the navigational purpose, of course, remains paramount, and the United States starts producing its own geodetic and coastal surveys, its own mapping of the seas, its own navigational ephemerides to give tabulated data for use in making observations of the sun at sea and reducing this information to get your latitude. So this is a Winslow Homer painting of exactly the same thing. I was in the Navy. When I went through Naval Officer Candidate School, I was disappointed that they had just dropped the class that involved taking people out and learning to use a sextant. And the rationale was, well, who's going to use a sextant anyway? Everything's electronic now, and that will never fail, will it? The Naval Academy dropped it, but then the Academy reinstated it, and now it's back again. The odd thing is, when I was in Naval Officer Candidate School, we still had a class in celestial navigation, but it was all the theoretical stuff and data reduction, but without actually making the observation. So unless you knew something about astronomy to begin with, you had no idea what you were measuring in that class. Now I'm going to survey the state of 19th century astronomy that would have been available to Philadelphians, mostly through a lot of these books. I've got a growing collection of early 19th century books on popular astronomy. And they're fascinating to review as a group to see how ideas are shaped over time and see how our ideas about our place in the cosmos begins to shift to something that we recognize today from something very different. The telescopes that were mostly in operation these days were of these two basic types. There were other types, reflecting telescope using both a combination of mirrors and lenses, the refracting simply with lenses. The favorite for observatories was the refracting telescope. And optics were improving such that they could create multiple sandwiched lenses that would effectively focus all the colors coming into that lens to a common point, which was not true in earlier centuries, which made observing very difficult. Now, let me start with this book, which is kind of fun, by this man named Thomas Dick. It comes out in the 1830s. Dick himself, and like most authors of popular books in astronomy, he had no formal training in astronomy. He was a clergyman, and he lost his patch because he had, an unfortunate experience with a younger woman, not married to himself, and that required him to leave his pastorate very, very quickly. He nevertheless turned his attention to astronomy, and I think we can thank his indiscretion for that, because he wrote some very good astronomy books. But this one's really notable. It's full of woodcut illustrations that accomplish an interesting thing. His perspective on the cosmos is really on the solar system. What lies beyond, the stars behind, at this point is really not something that one can investigate. Simply assume something is out there. Possibly these stars are sun-like objects. That opinion is not definitive or accepted by everybody. But by this point, some new things are happening. The diagram at left shows two prominent bodies in the asteroid belt that were named Pallas and Ceres that were discovered about this time. So after a long period where nothing new had been discovered in the heavens except comets, we've got these two new planets from the late 18th century, and now we get these smaller planets that are starting to show up between the major ones. But one thing that's fascinating about what Dick does in this book, he has woodcut illustrations depicting what it would look like if a human being could visit other planets. And as if one was standing on another planet and looking out, what would one see? And so the artist making the woodcuts was guessing at these kinds of viewpoints. And this is very unusual and probably among the first books to introduce that thought experiment. But at the same time Dick is publishing this, the second great awakening is happening in the United States, which is an evangelical fervor that really just overruns the entire country. You see these huge gatherings of people outside of cities where they're listening to speakers, they're camping out for days. You see tents in the background, and they're evangelizing each other. This evangelic fervor makes its way into astronomy books and stays there for a very long time. Now, at the same time, of course, the U.S. has this emerging tension about slavery. Civil War hasn't happened yet. I think we've probably all heard through other means, movies, other literature about enslaved people making their way north by following the North Star. And to understand that configuration, they had to recognize the Big Dipper in the sky in order to follow those two pointer stars, as you see at left, to get to Polaris. And then the photograph at right has those stars highlighted. The idea is the song Follow the Drinking Gourd being the Big Dipper, was the way to develop a little mnemonic device for finding the North Star. Now, unfortunately, the scholarship on the origin of following the drinking gourd kind of places it after the Civil War. But it doesn't really make any difference, because there's no question that enslaved people traveling north would make use of celestial reference in order to get where they wanted to go. So celestial navigation works a lot of ways for a lot of people at this time. But at the same time, if every household had a Bible, it also had an almanac. And after we stopped importing so much astronomical literature, including almanacs from Europe, we start creating our own. And this is maybe one of the most famous early almanac makers, Benjamin Banneker. And no house would be without this. And you can still go to a drugstore and find on the magazine rack a farmer's almanac. Now, it has less in it than it used to, but it still has the astronomical information about phases of the moon, even some advice about planting, and it still has that yearn towards the days of the farming communities of observing the cycles of nature in order to raise crops and raise livestock. Which brings us to Elijah Burritt. One of the things that Dick mentioned in his book, he says, what this country needs, and he meant the UK as well as the United States, is somebody to write a good descriptive overview on astronomy that could be of use widely for adult reading and also in the schools. I picked up a copy of this handbook, The Geography of the Heavens by Burritt in Upper State New York. It's my first rare book that I purchased for $1 in New York. It's an 1866 edition, and it's hardly the first edition of this. Elijah Burritt was by turns a blacksmith, a teacher of mathematics and other science topics. And he came to understand this is exactly what this country needs, is a good handbook on astronomy that could serve as a textbook with guides to teachers and student learning incorporated in the book, as well as try to come up with the latest state of things in astronomical discoveries. There was a lot of emphasis in this book on naked eye astronomy, but after Burritt died, it continued in print, and an astronomer who edited later editions included a lot more information about observatories and telescopes to urge people to look through them, look through telescopes, not observatories. I always take note of where my books come from if I can, and mine had a signature, an ownership signature for the Friends Academy in Union Springs, New York. And it's a very interesting tie-in to education at the time. A short distance from where I bought the book, this academy was one of the first co-educational institutions in the country, small, Quaker run, and it particularly prized learning in mathematics and early scientific subjects. So at some point that school dissolved, and this book exited the library and ended up in my hands. So I'm quite pleased to have it and what it represents. Now, this handbook accompanied a very colorful and very popular atlas. And believe me, you're not going to find one of these in a bookstore for $1. They're very rare to find complete, and there are thousands and thousands of dollars now. But they're very colorfully illustrated, as you see here. And they had to be, of course, hand-colored after they were printed in order to get this. There were the cheaper non-colored editions, the more expensive colored ones. So you see the constellation figures in their mythological guises, but you also see the grid system and the stars identified on the celestial globe, so that people could actually use these to make calculations as they would do with an early star finder or planisphere. And this is an example from his book. You see at the bottom of the page, the open book at the bottom of the page, there are questions for the student to check oneself with, or for an instructor to use. And you have questions that are geared specifically to the anatomical atlas, such as up in the upper left, given a particular day and month, where will the stars be when they cross the meridian, the imaginary line going north to south overhead, on this date in January? And then on the map, if you look up the solution, it tells you where to look to find it. You could solve that same problem just by looking at one of those star finders or a planisphere. And even today, it's like a 20-second solution just by moving that star circle around. So this is Elijah Burritt's book. It was the single most popular textbook on astronomy in the United States. It was in print all the way from the late 1830s to the 20th century, before it gave way to, of course, other more modern texts that included photographs. But the information on the celestial sphere, on how eclipses work, all of that, that's where I learned it. My first real learning about astronomy was through that particular book. And my orientation to the celestial sphere was from that 1866 copy that I have. But let's not forget there are also books being produced for children. There's a series of books on different topics by this Peter Parley. He's simply a benevolent old guy who walks around on a cane, who loves to talk to children about various topics. There are two versions of astronomy Peter Parley books. The one on the right has this gift inscription, Anne Helen, who gave it to her nephew in 1859, which I think is pretty cute. This one is oriented more towards, I would say, about third graders today. The book on the left is probably oriented to somebody about 12 or 13 years old, but the reading level is almost college level in it. And it has much more detailed descriptions of how things work in the observable universe, the celestial sphere. That's all gone through in this book. It doesn't have the Burett book doesn't have the moralizing that occurs at the end of the Dick book, which concluded with messages about regarding God, regarding his great plan for the universe, and future discoveries as God permits. We will have into his magnificent universe in time. So, come back next year for another book. These books for children are exactly the same way. They're highly moralistic, but they give good astronomy. And this is a good example. Nice woodcuts, not sophisticated illustrations. And I'll just have to read along with this concluding bit because it's so common in all children's books at this time, whether it's on science or anything else. It would give me great pleasure to know that my little readers have been, all of them, pleased with these stories. To an old man that is now gray and lame, it would be a matter of delight as he hobbles about the streets to see in the bright faces of the little boys and girls a smiling, "Thank you, Mr. Parley. Thank you for your stories. But to tell you the truth, I have a deeper wish than this. I have sought to give you pleasure, but I am more anxious that you would be wise and good. I have not forgotten that you have a life to live here and hereafter, and I hope you will never forget that happiness is the lot of the virtuous and misery the certain doom of the wicked." Which brings me to Mitchell, Mariah Mitchell. Now, to just counterbalance the moralistic tone for children, for adults, one of the comments that Thomas Dick makes at the end of his book, and it's a good way to leave the reader, and it's something that we could all resonate with now. He says, "Astronomy is calculated to convey a lesson of humility and humanity to those proud and ambitious mortals who glory in their riches and who fancy themselves to be a species of demigods." So obviously a moralistic subtext to that one. But at the same time, there's a Yale University astronomer who says in a popular book the following about astronomy and contemplating the heavens. "The emotion felt by the astronomer is not that of sudden excitement or ecstasy, which wears out life, but it is a continued glow of exalted feeling, which gives the sensation of breathing in a purer atmosphere than others enjoy." So we come to Mariah Mitchell. Grew up in New England. She was a daughter of a man in a Quaker family who had a passion for astronomy and even built a home observatory, and she observed along with him. Well, when she was 16, her education was officially finished, and she immediately opened a school for girls to emphasize math and science, and astronomy, of course. And in her case, she got lucky with some of her own observations. She ends up becoming the first professional woman astronomer in the United States. She's the first American scientist to discover a comet. She's the first woman to be a professor of astronomy in this country. And with a 2-inch telescope, she discovers a comet. This gives her worldwide renown. And as a result, she's elected to the American Academy of Arts and Sciences in 1848, the first woman to enjoy that distinction. She becomes a professor at Vassar and becomes an extremely popular lecturer, as well as acclaimed for her scientific accomplishments. Now, the observatory telescope you see on the left, I think it's a 12-inch telescope. That would have made this one of the largest telescopes in the country. I think it was in the top 3 at the time this was built. And it continued to contribute to science for a good long time. Now, the observatory dome you see in the center building there, but in order to teach astronomy to women, she had to make break some rules. And one is young ladies don't go out by themselves at night, particularly in the wee hours of the morning, but you can't do much astronomy if you don't go out at night. So she proudly let her students out at night and stayed up all night observing if the situation demanded. They'd all array themselves on the top of that building and look up and sit in blankets when they weren't needed and listen to lectures as Mariah would hold forth. She also was notorious in a good way, for her conviviality among her students. She had quite a loyal following and was considered a brilliant teacher. She held dome parties and would invite speakers in, including people who were popular speakers on the social issues of the day. Julia Ward Howe, for example, from Civil War fame, was a lecturer here. They would have parties where they just have fun, and they'd take out scraps of paper and they'd write doggerel verse about each other using astronomical imagery. And they had good fun. One of the students that that she had shortly before Mitchell died in 1889 wrote to her a note that said, "In all the great wonder of life, you have given me more of what I have wanted than any other creature ever gave me. I hoped I should amount to something for your sake." And I think that's a hell of an epitaph to have. With her students, she actually participated in scientific expeditions and got funded for them, as you see in the upper left, which is an eclipse expedition to observe and measure phenomena associated with the solar eclipse. And here you see several women at their telescopes. There's a class picture on the upper right with a very specialized telescope called a transit instrument, which only moves in a north-south meridian, and it only measures and times objects passing the meridian. They need to be timed and measured in order to properly chart the sky. Very important for navigation. And Mariah's classroom is down there at the lower right. Looks pretty much like a classroom today. So moving on to these decades closing in on the end of the century, we start to have more books of the Elijah Burritt character geared to schools. And this is a good example. The ownership signature is from Edna Varney, class of 90 in Skowhegan, Maine. And she has Astronomy for Schools and General Readers. These books are taking up a question that is very common in popular lectures on astronomy, which are very well attended. People always want to know one big question, and it is, are there people out there? And where are they? This book has a special topic in the book for teachers and students to study on this point. Are the planets inhabited? Question of great popular interest. Most astronomers by this point are trying to deflect the question, saying it is not much of scientific interest because we have no means to investigate it. We may see something through a telescope that might look like evidence of life on another world, but we are far from being able to say that that is the case. And it's going to require bigger and bigger telescopes or some other method to find out. But about this time, a major innovation has occurred and is changing astronomy, and it's starting to appear in astronomy textbooks, and that is spectroscopy. Here you have another book by a minister, and it's not uncommon to find popular textbooks on astronomy by people of the clergy who want to combine essentially a message about the divine with a very good description of the cosmos, on the assumption that this is the best way to enjoy God's magnificence in his creation, astronomy. It's a science ideal for the purpose. So here you have colored plates in this book from the early 1880s that show spectra. And it's a reminder that when it was possible to point a spectroscope at the sun and look at the sun's spectrum, which is the top line in this diagram, a new element was discovered, happens to be helium, discovered on the sun rather than on the earth. So there's widespread interest now. And up to this point, astronomy books have not said anything about chemistry, have not said anything about geology, but both those sciences are now starting to show up in these books. Chemistry, because spectral analysis is also chemistry. Also, the geology is showing up because the book you just saw from Maine and this one are now considering the Earth a little bit differently. They're looking at it not as an anomalous sphere where God has created a Garden of Eden and all subsequent life, but it's a planet. It's a planet that is made up somehow of material, probably not unlike the material that makes up the other planets. There's also questions about what's out there beyond the solar system. It's already believed that there are trans-Neptunian objects out there waiting to be discovered. That's widely held to be a belief, even though none have been identified at this point. Planet Pluto, or the minor planet, or the escape planet, or the weird planet, whatever we're calling it these days, hasn't been discovered. That won't be discovered until the 1930s. But we're starting to think about what else is out there. Telescopes can see stars. The most powerful telescope in the world is going to show the same star that a small telescope shows because they're so distant. But now that we can apply spectral analysis to stars, we start learning different things and seeing that stars can be different from one another. And also, we're starting to see the sun as a star and not as simply an anomalous object that we have to figure out. And even up to this point in the 19th century, there was still serious thinking that the sun might have had a surface that's habitable. And that was apparent when sunspots appeared. It was thought they could be a glimpse into some underlying stratum where life exists. So we have a far distance to go to really get the measure of the sun as a star or get the measure of stars as stars. But also, what's the larger configuration? Where do we fit? Where does our solar system fit? Through any of the telescopes, we can see stars, we can see clusters of stars, and we can see nebulosities. Now, some of those today can be resolved into galaxies that are immense systems with billions and billions of stars a long distance away from us. But it was not possible at the 19th century to do that. It was not possible to discern that our Milky Way has a particular structure and we're in it somewhere, and our star somehow goes around a galactic center. This idea is not quite there yet. So this man here, Proctor, is one of the popularizers who's trying to take a big stab at looking at the larger picture. And this little diagram you see from his book, Other Worlds Than Ours, that looks like a pretzel, is his idea of what the Milky Way might look like. Now, you got to give him credit here for the spiral arms that emanate from a nucleus as we know today. He's got arms in there, but they sort of fold back in on themselves. The S dot that's identified there is supposed to be the sun. And that's its place in the larger scheme. So we're starting to see the effort to look outward and to guesstimate about what's going on everywhere else. Now, one of his thought experiments I thought was pretty cool. At this point, there have been multiple measures of the velocity of light. It's been possible to measure stars out to a particular distance through parallax measurements and using the Earth's orbit as a baseline from 6 months to 6 months and take observations on either end of a star out to a certain distance. You can look at that star with respect to the background of stars, and that background shifts. So you can do that up to a certain point, but beyond that, you can't. And there was no way to measure extreme distances, much less get any gauge at all on the size of the larger universe. But Proctor did an interesting experiment about light travel and light traveling at a finite speed, which was known at the time. It had been measured multiple times since the 17th century. So it was known to travel at a finite speed. And he says, imagine if you're on Neptune and the Battle of Waterloo is in progress on the Earth. And you look through a telescope and you see an image like this of the Waterloo battle in progress. But the British and the British allies are losing, and Napoleon's advancing, and it looks like he's going to claim the day. And what you do not know is that at that moment, you're receiving that light, giving you that moment. On Earth, the battle's concluded. And the fortunes of war switched on the battlefield as soon as the Germans arrived. And the British and the Allies won the day, and Napoleon had to quit the field. So those Neptunians wouldn't know that for hours. So I thought that was sort of a cute and clever way of, just as we do today, in trying to communicate the time lag in the huge distances involved in the cosmos. Of course, how many people know about the Battle of Waterloo and how it worked anymore? So what we have in all these texts, to sort of sum up where we get by the end of the century, we have an emerging hypothesis, a nebular hypothesis about how the universe is, well, how the solar system is created. The larger universe, we can't go there. We don't have the means to that. We also don't have a way to really plumb the depths. We know when we open up a telescope to some part of the sky, it's going to show stars you can't see with the naked eye, meaning these are stars that are much farther away. And you can rationalize that, well, if that's the case, an even bigger telescope is going to show more distant stars. So you know it's going to go on and on and on and on. And a common belief is it's just infinite. That's just the way it is. But there's no discussion at all about how the universe originated. In fact, the word universe isn't really used much. We have the advent of spectroscopy and chemistry, which is going to be a big deal. And of course, into the 20th century, it's going to propel an understanding and a creation of this whole body of physics, quantum physics, and the insights that delivers to understanding cosmic phenomena. Einstein, for example, comes along. We continue to have discoveries of more asteroids and planetary moons, Comets, we're still trying to figure out where they come from, why they come in so fast, and why they leave, and some never heard from again, and why some are periodic. We are curious and asking questions about what's beyond the limits of our perception, Neptune and beyond, and suspecting that there's more planets out there. We also now know that stars are not static. There's proper motion. They do move, and they can be measured. And if we can do a comprehensive map of all the stars' movements, what would that tell us? Are they all moving the same direction? Are they moving away from us? Are they moving towards us? And this, of course, is going to link to spectroscopy and understanding movement to and from spectroscopically, the red shift and the blue shift, which is something that's going to be decades away. Speed of light has been ascertained multiple times. Photography has now entered the game, and it's been discovered that photography can be a legitimate scientific tool in its own right. You can record phenomena on a plate and even measure it on a photographic plate. So that kind of work has begun. When I worked at the Naval Observatory, they had plates going back for quite a long time, just to try to measure proper motions in stars and changes over time. Well, one thing that's very interesting to harp on for a moment is the fragility of perception. The idea that astronomy involves a lot of assumptions and conclusions made on indirect evidence. And we can't see the distance to a given star that's maybe 5 light years away, and the term light year isn't in use yet, even though they have determined that this is 5 times what it would take, speed of light, all that to get there. And they've speculated that, well, that makes some of these stars like 60 million miles away or 60 billion miles away or whatever it is. And they'd sort of leave that with a question mark. Could this actually be true? So when it comes to astronomy, these astronomy books over time spend more time in talking about the limits of what we can see, the limits to our understanding, the limits to how we might even self-deceive based on data that we misinterpret. And it's interesting to see that, because there's a recognition that when you talk about planets, when you talk about orbits, there's no conventional frame of reference of up and down, north, south for the most part. We have to think in different terms. And so these textbooks begin to help develop a more expansive point of view that needs to be opened up and will be opened up much, much wider when quantum physics starts to enter the game. So let's wrap up with Professor Mitchell's Tour of the Sky. And this isn't Mariah Mitchell. This is the most popular astronomy lecture of 19th century America. Neil deGrasse Tyson and Carl Sagan are the Ormsby McKnight Mitchells of the 20th century and 21st century, not the other way around. This man was sort of hardscrabble beginning, impoverished farmer son in Kentucky with an aptitude to mathematics. He gets into the military academy, the West Point Military Academy, and becomes expert in engineering and mathematics. He carries his astronomical interest. These books on the upper left, the 2 brown-covered ones, are his 2 most famous books that were essentially public lectures that were turned into books. And again, as I said earlier, these are pitched at a higher understanding than you would expect an equivalent book to pitch today. And it assumes a more sophisticated reading ability than we would give to most adults today. But Mitchell became quite a popular lecturer with these books, and he ends up founding an observatory, which we will see in a moment. But along the way, the Civil War happens. And because Mitchell had been in uniform for a while, he was West Point trained, they call him back into service, make him a major general, and they make him part of the Union operations early in the war in Kentucky and Tennessee. Now, why do I have a picture of Buster Keaton here? Mitchell was known as Old Stars by the troops because of his astronomy interest. You can imagine him at night gathering soldiers around wherever they're camped, saying, "Hey guys, I'll give you a lecture on astronomy tonight. Just sit close and listen." Well, an episode took place where he wanted to sabotage the Confederate railroad system. And he handpicked a series of what we'd call commandos today, sent them down sort of incognito down south, where they captured a train in Georgia and then stole it and took it north. The idea that stop on the way and burn all the bridges and mess up the railroad tracks behind them. Well, it didn't quite succeed because the Confederates managed to muster up a locomotive to go in hot pursuit. And for 87 miles, that one train chased the other one until the one the Union officers, the Union soldiers had commandeered, ran out of fuel. And so they abandoned the train, but most of them were caught and executed as spies. And the others got away, but ultimately this was not successful because they had no chance to stop and destroy anything. They simply created this locomotive chase, which got in the popular imagination. Walt Disney made a movie about this episode called The Great Locomotive Chase. And Buster Keaton's, one of his most famous medals is called the General, where he's a Confederate stealing a train and single-handedly combating Union forces. And you can get this on the internet. You can watch it. It's a full-length movie. It's hilarious. It's one of his best, and the stunts are extremely dangerous. So this is Mitchell's, the observatory he founded, and in order to get it done in Cincinnati, he had to issue shares, popular subscription. And for buying a share in the new telescope, you enjoyed unlimited viewing rights through the telescope. I wonder how that was arranged. And the telescope has been refurbished, and there it is today. Still a functioning refracting telescope. That's the beauty of these old telescopes. They still work. So if he was observing with that telescope, let's look at what he's looking at on a given night. He's looking at the moon, and that's his drawing on the left. And this is a map of his era about the moon. The moon, we know, has had a volcanic past, and those large areas called the lunar oceans are essentially lava flows that occasionally swamp and partially disguise or completely disguise craters made by impacts from the very early creation of the solar system. Now, this morphology was not understood at the time. There was still a view that there still could be people inhabiting the moon. You could see through the telescope that there were deep craters. Even the most powerful telescope would not be able to tell you if there are beings building houses and building roads. But the idea was still fresh that maybe that's possible, and with larger telescopes, we will get more at this. But when we get to the planets, I have Mitchell's drawings on the left, which very much approximate a telescopic view for, say, me with my telescope. The image on color towards the right on the top is a telescopic view comparable to the one he would have had. And a spacecraft view or Hubble Space Telescope view is shown in lower right. Mars was an enigma. Could it be inhabited? Possibly. It was in the 19th century that the canal idea surfaced and was taken up only really by a handful of astronomers. But this is a good example of the caution about perspective and belief and disbelief in what you're seeing. The eye can be a deceiving thing, particularly when the brain wants to create patterns. And it was finally agreed that these canals on Mars were linkages imposed by the mind trying to connect these darker areas of Mars that were believed to possibly be vegetation. They aren't, but at the time, this was a working idea. Jupiter was the most fascinating one. This color image was published in Proctor's book, but that's pretty much the image that Mitchell would have had. But there's a photograph of it, telescopic image in the upper right, comparable to what he'd see. It's what I see in my telescopes. Because of atmospheric turbulence, which is never ending, you have to occasionally be very patient in moments where it clears for an instant and you get this great detail, which you try to jot down or copy. Today, amateurs and professionals can do all kinds of digital photography to capture all those best moments and cement them into a single image. And here you see a spacecraft image below of what those clouds look like. Now, Mitchell and others thought that they were looking at the surface of Jupiter and also a place that could be inhabited. But we know that Jupiter is encased in clouds, and there's probably no solid surface at all, just increasingly murky density as you go inward. And if there was any kind of a ground underneath those clouds, a human being could barely stand up. You'd weigh about 400 or 500 pounds. Also, there are moons to these worlds that are being observed and their orbits calculated, but there's not much that can be done telescopically to figure out what they are. Saturn, everybody's delight. The ring at that time was thought to be the only ring in the solar system because of its high visibility. Galileo was able to see this, although he wasn't sure it was a ring. It looked like something else through his telescope. but it has similar cloud bands, but there's not much else that could be done telescopically with it because it's twice as far away as Jupiter, more difficult to see, and even that spacecraft view towards the lower right or lower center is about as good as you can get, although there's serious amateur and professional programs to document changes in the clouds and therefore the atmosphere meteorology of the planet, as with Jupiter. But the Milky Way, to Mitchell, looked like the upper left. That's his drawing of what he thinks it looks like. Mitchell cannot see that nobody else can either, that the Milky Way is essentially a star system. The fact that it's a nebulosity is difficult because there are other objects in the sky that are nebulosities that are very different things. So he is still thinking that this is a big system, we're part of it, it's incompletely known. The best current scientific view is right down in the lower left. That's what we look like in the best estimate. When I was a kid, the image of the Milky Way galaxy was even different from this. So we continue to learn. But he is not able to speculate. Mitchell cannot really go much farther than, well, we don't know exactly what this is. It could be a large system. And he speculates that objects like this might be significant components. There are globular star clusters, that is, so many stars clustered in so tight a space, relatively speaking, that they show up like a big hairy ball spinning off little points of light. The telescope appearance that Mitchell would have had is like the one in upper right, which is a drawing made by somebody looking through a telescope. And that's what Mitchell would have seen. And he's assuming there are lots of stars clustered close together. These globular clusters tend to congregate in our Milky Way in that large halo around the nucleus and frequently contain much older stars. But they are beautiful sights in the sky and can be seen sometimes like this one on a dark sky, even with the naked eye, as a faint patchy fudgy area. Looking at a very different kind of nebula, the Crab Nebula, this is what Mitchell draws on the left. And he assumes that it's a nebulosity that contains many, 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 many stars. And so he has those little bright pinpoints. Well, we know now that it's an exploded star. And what we see through both telescopes and spacecraft is the photographic image you see, which is essentially the outburst of a supernova about 1,000 years ago, at least 1,000 years ago in our time when we first detected it. And there is the remnant of that star in the center of that today that can be observed. So the best telescopically is still this fuzzy patch, and trying to make sense of all these different fuzzy patches has been a big, big obstacle. One phrase that both Neil deGrasse Tyson and Carl Sagan make today is that galaxies are island universes. Well, Mitchell may have been the first to use that, but he used that term for those clusters, globular clusters, calling them island universes. A different kind of nebula, but also another one where that is a star-making factory. It's one of the most brilliant objects in the sky in this category of nebulosities. It can be seen with the naked eye under the right circumstances. Even sometimes on a dark night north of Philly, I can see it. But on the right, you have these three stars at the top, obliquely Orion's belt. That luminous thing down below is the Orion Nebula. What Mitchell saw is at the upper left. A good view through the comparable telescope today yielded the drawing that you see there on the lower left. And it's a beautiful sight. It has a greenish tint at night through a small telescope. And it's a stellar nursery. There are small stars that you can see that were born of that larger nebulosity over time. So rather than an end product like the Crab Nebula, this one is sort of a starting nebula. And there is another image of it. Extremely bright, and it has quite a romantic appeal, particularly on public observing nights at major observatories. People would love to see this. When we get to this other kind of nebula, which is a real galaxy, this is the image upper left that Mitchell sees. Over on the right, that's what I see. That's what almost anybody else sees through a telescope, unless you use long duration photography with film, or you're taking multiple images from the James Webb Telescope or others that can reveal an image like the one you see at lower left. And that's two galaxies in that picture. There's one at the lower right of that, but that's the Andromeda Galaxy. That's the closest spiral galaxy to ours. So at this time, we do not know that the Milky Way is kin to this. and is part of a universe where both Milky Way and Andromeda are galaxies, are star systems that are huge, extremely distant from one another, but very similar and similar in their evolution. All that is yet to be found. But the promise of astronomy has not gone away. And to take it back to Proctor for just a moment, he concluded his book by saying, the history of our world is in truth bound up so intimately with the history of the universe that the grain of sand or drop of water conveys not only the whole history of the world, but with equal completeness, the history of the whole universe. That speaks to today, but it also speaks to the forward thinking of people like Mitchell and Proctor, who are trying to reach beyond the known with each subsequent generation to surmise about what's next, how else does this work, and leads us into the 20th century. So the sun is about to rise. We conclude our brief Mitchell tour of the sky, and I'm open it to questions, but I'm going to show you this one last quotation from Mariah Mitchell about science. We need imagination, not just mathematics and logic, but it is somewhat beauty and poetry. A recognition we make now, a recognition she wanted to teach her students, as well as the mathematics behind all this. Thank you for this opportunity.
Thank you so much, Robert, for your talk. It was wonderful. We see applause coming up in the responses. And I have a few questions already in the chat room, which I'll read out, and then everyone is welcome to add some more, and I'll pick those up at the end. So the first question was, were these models of the stars and the universe and these early tools created as being geocentric with Earth at the center, based upon the belief of some divine creator, such as the Judeo-Christian God creating the heavens and the earth?
The sphere in the middle is the Earth, and it was conceived at a time before Christianity. We know the ancient world had conceptualized this kind of thing, and the idea of a celestial sphere. Stuff that some of us were taught in school about, like Columbus was trying to prove the world was flat and all that stuff. Every educated person knew that the Earth was a globe, knew the planets, well, when they could start to see them through telescopes, could see they're also globes too. And but the idea that the Earth was the center was certainly inherent in the design of those early armillary spheres. And I made the point earlier that despite that, it is still the model that we use in navigation. We assume a stationary Earth because we don't need to worry about its motion through space for navigation on the planet. And so everything that we observe is, of course, apparent. The sun does not actually circle the Earth, but we call sunrise and sunset. It's really Earth set and Earth rise, if we want to be real technical about it. So we still use references that are convenient in our daily experience that assume a geocentric Earth. But navigation finds that model still useful, but astronomy, of course, has gone beyond it. But for learning how the sky apparently works, that is, these celestial motions, if you want to understand risings and settings, it's very easy to imagine all the stars on a common sphere around the Earth, which of course is not true, but we can imagine it and then understand the shifting sky, the shifting seasons, and so on. It's a convenient model. It's one of the most successful scientific models ever developed for its longevity and use, even though it's a geocentric Earth at the middle. So over time, this is overlaid by Christian ideas and Christian values, as it's taught in European universities, for example. If anybody wants to say, well, how did this all come to be? Well, God created it. But those aren't questions that they explore. It's a descriptive astronomy to understand apparent motions. That's the focus of understanding. And this is pious work because it's a way of gaining insight into God's creation. So it is by virtue of learning astronomy, it's an act of prayer.
Mm-hmm. Very good. So the next question is the U.S. Naval Observatory telescope 26 inches in aperture?
I should have clarified that. When I refer to a 12-inch telescope or 26-inch, it refers to the diameter of the lens on the far end of the telescope. Or if it's not a refracting telescope and it's just an open bucket like a reflecting telescope, it's still the same thing. It's a diameter of the mirror in that case, or the lens. That's what it refers to. It gave great hilarity to my mother, who gave me a lift when I was a college student to the Naval Observatory, because I worked in the astrometry and astrophysics division for 2 summers. But right next to the parking space for the director of that, there was a space that said Director 6-inch division. The next one over said Director 7-inch division. My mother interpreted that in a way I probably don't want to go into, but she said, have I seen the directors of those 2 divisions? What is this? And I said, it refers to the diameter of the telescope, the transit telescope that they're using for measurements of star positions. There are 2 different ones at the Naval Observatory, one 6-inch, one 7-inch, and that there's a coterie of people and there's a division director. And she said, yeah, right. But she had more fun with her interpretation of what 6-inch and 7-inch meant.
Mm-hmm. Yes. Okay, so the next one is, can you speak about the contributions of David Rittenhouse of Philadelphia to astronomy, and also about his educational background?
Oh boy, it's been a while since I've dipped into David Rittenhouse. But what I can recall, I can't recall any specifics, but he's really a good example of a couple of things, both the atmosphere for learning and the desire for learning, and the fact that disciplinary boundaries that seem so rigid today for professional occupations definitely were not so back then. Witness the people, these clergymen writing these textbooks on astronomy, for example, or Elijah Burritt. I mean, he's essentially self-taught in astronomy and applied himself when he was not blacksmithing, for heaven's sake. So Rittenhouse fits that mold. You get these 18th century guys who are in a town, in a city that has a lot of intellectual ferment to it, a lot of interesting exchange of ideas, and he applies himself and does well. I'm sorry, it's been so long since I read about David Rittenhouse, I can't give you much more than that. As you probably know, there's a Rittenhouse Astronomical Society, a very large amateur following, and their website, I think, has some more information on David Rittenhouse's background. I've seen his name invoked more often than I can count without knowing all the specific achievements he made to go along with that. And I would just say, as a tail end to this, Philadelphia contributed to the advancement of astronomical understanding in some significant ways, and one is in navigation. I showed you a Winslow Homer picture showing 2 sailors at sea with sextants measuring altitude of the sun. That particular instrument, the sextant, or its cousin, the octant, they were identical except the measurement of the arc was different, had a simultaneous invention in the United Kingdom and in Philadelphia, and a man named Godfrey, who's buried at Laurel Hill Cemetery, and there's a little sextant on his obelisk. So he gets equal credit in the scientific world for innovating this immensely useful navigational astronomical tool. Rittenhouse is part of this whole milieu where he's discussing astronomical ideas, self-taught, taught through conversation with intellectual equals. And man, I'm sorry I can't illuminate it more than that offhand. I have to review my materials.
Very good. Next question is, what, if any, role did astronomy play in the Enlightenment or deism movements?
Oh my gosh. Well, when we talk about the Enlightenment, 18th century Enlightenment and the Founding Fathers Enlightenment, and that brings to mind Thomas Jefferson, frequently portrayed as a deist. Astronomy has helped configure some of those views in a way, just as I mentioned the Second Great Awakening in the early 1800s that spread throughout the country, this vast evangelical movement also was a push to popular astronomy because, again, it's a way of enhancing your worship and appreciation of God. Deism does have astronomical and other scientific threads feeding into it, just out of some of the Enlightenment theory ideas that tried very hard to separate essentially rational inquiry from religious dogma, and whether it was Christianity or anything else. And of course, Thomas Jefferson, who had plenty of slaves to deal with all his daily needs and could spend his time doing scientific things and inventing things, was very much part and parcel of that, and was supremely learned in astronomy, as he was in a variety of other scientific fields. And that, I think, is edging in a direction that caused the so-called big split between scientific endeavor and religion. And deism sort of figures into that chain of events. The historical view now is that there really wasn't that kind of split. There were debates that took place, but there's been a great deal in science today to try to even mollify that lingering idea that science and religion are diametrically opposed. And even in the United States, I mean, look at the textbook banning and everything else, and opposition to vaccination and refusal to believe germ theory, where you get this resistance to these ideas. Some of that resistance is still tempered by religious thinking in some quarters. I think I may be drifting from your subject because I don't know if I can give a better definitive answer with that, other than to say there is a thread, there are multiple threads from developments in astronomy and understanding our place in the universe and other avenues of scientific inquiry that are pushing deism forward. And I've even heard that term mentioned recently. I heard somebody in an interview somebody in a scientific field say, well, I'm just a deist these days. And it just sparked with me that word's still out there and people are still identifying with it. I don't want to keep talking about it because I'll just go into territory that I just don't know very well.
Okay. Yeah, there was a comment that came up. The moon's dark terrain, Mariah, I believe, were formed by lava flows following impacts, not volcanoes.
Thank you for that correction. Yeah, you're right. Right. Yes, not volcanoes. It was believed at the time that those craters might have been volcanic craters. That was at the time, not now. The lava flows were not appreciated as lava flows in Mitchell's era. So the speculation continued. What exactly are we looking at? We can recognize mountain peaks. We can see the shadows of mountain peaks. But any sort of lunar geology was still way in the future. And that doesn't really kick off until the 20th century.
Mm-hmm. You spoke of astrolabs followed by planispheres. Those have been superseded by smartphone sky apps. What's your perspective on that?
Oh, I don't know. I on one hand, any way you could access the sky, that's fine with me. But science museums, science centers still sell those. You can get them on the internet quite easily. There are multiple manufacturers of them. But smartphones have made big inroads into armchair or casual astronomy. I met a man in the Philadelphia area who has a little backyard observatory, but he doesn't look through any of his couple telescopes. He doesn't at all. He sits inside the house with his laptop connected, and he does imagery and image processing through his computer. That's very popular. There are telescopes now sold with smartphone holders on them. You download a certain app to your phone, you stick it into this holder on the telescope, and it now becomes as we call in this technology, a go-to telescope. That is, it's a GPS-guided telescope that has a controller that has thousands and thousands of celestial objects encoded in it, that once your telescope is GPS-oriented, you can just say, I want to see the Orion Nebula, and boom, the telescope goes there. And it can be done through the iPhone. So it's made casual astronomy much easier. And I think probably gives a lot of casual people, that is, people with a casual interest in astronomy who don't want to have an observatory, don't want to have a sophisticated telescope, but want more than just going out and looking up. It allows them to do something that they might get frustrated with. One of the worries in astronomy education in previous years that people might get interested in astronomy and go out and buy a telescope. Well, you might buy a junky one that wasn't really any good, or you might buy a good one, but you would find it hard to use until you had mastered use of star charts and understood the celestial sphere and all of that. Well, an iPhone kind of cuts across all that, because if you want to see the Orion Nebula and you don't know much else about the sky, the seasons, the sun and the moon, your smartphone will take care of it for you. Link to a telescope, and it will just take you where you want to go. I have a telescope that's GPS controlled, and it has carries a control device that has 42,000 objects in its database. And it's even sophisticated enough that once you get on the object, it will follow the object overnight. But if you want to study the moon is actually moving over the course of a night. You can adjust it to the speed of the moon so it follows the moon. And the telescopes will do this for you now. And so given the fact that Philadelphia skies are so heavily polluted and naked eye astronomy is kind of difficult, I tend to rely on the go-to feature when I want to get to something that's relatively faint rather than try to look at it using a star chart in one hand and guiding it with the other. I'll use that feature and the GPS and go right to the object. But I think the impact of phones is it's enhancing interest in astronomy, and you see that in the industry of making telescopes with far more starter scopes, the small scopes, portable, take them anywhere, that are all GPS connected and also adaptable to smartphones.
Mm-hmm. I see in the chat there's a little discussion about individuals' experiences with telescopes and modern telescopes. But the last question that I have so far is, do you know if Thomas Jefferson had an observatory at Monticello?
That's a good question. I don't believe he had an observatory at Monticello. I've been out there, and I actually had that conversation with one of the people at the place years ago. He apparently didn't have one, but he had a telescope. And it would have been where he was situated, where Monticello is situated. It's on a hill. It's away from Charlottesville. It certainly wouldn't have competed with city lights from Charlottesville. Would have been nothing during his era. All he had to do was open up some of his large windows, set the telescope up, and he has a view. Because he had very, very large windows that were sort of one row on top of another. You could open them up like an observatory where you have that big slit in the top of the dome that you open up. He could do that with windows on his ground floor. And he could set up a telescope right there in his parlor and look up and see stuff. Or take a table out on the lawn and do it there. The advantage inside is he also had his chronometer. If he wanted to make timings of anything, he could do that. We know he made scientific observations and recorded them on all kinds of phenomena. But no, he didn't have a purpose-built observatory, to my knowledge, and no one's found any evidence that he has.
Okay, great. I'm going to, if there are no other questions, I'm going to turn this back over to Eric to wrap it up for us. And while I'm doing that, I'm going to put a link to your latest book in the chat so people can look up your latest book. And perhaps, Robert, you might be speaking to us in the future about that book. We would love to have you.
Happy to do it. And I should say that, yes, Indiana University Press. Also, the book is coming out as an audiobook in January as well. So I'm curious to see how that goes. I don't know. I have an image on my screen, the very last image of my PowerPoint. Is that still available to you? That says
Yes,
Central
that's
High
up.
School? I'd like to make a little plug about that. Central High School had one of the most sophisticated physical sciences department in the country in the 19th century. And it even loaned equipment for innovative medical treatments during the Civil War. But you see at the top in the old building that no longer exists, there's an observatory. It had an observatory. Unfortunately, it was destroyed in a fire. But the physical sciences laboratory at Central High School, a lot of the old 19th century instruments still exist. And in the library of current Central High School, I found, for example, this telescope just stuck in a corner with a bunch of books. Well, that's a perfectly useful telescope and needs to be cleaned up a bit. And it's a refracting telescope. I don't know if it's still sitting there in a corner, but I was there to evaluate a book that turned up that turned out to be a guest book from a British private observatory in the 1800s that happened to have a who's who of names in it, from Florence Nightingale all the way to Ormsby McKnight Mitchell that I talked about, who'd visited this other observatory. They sold that off for a private collector to raise money for the school, but I think they still have the instrument. So if anybody has this inclination, you might want to contact the library at Central High School and see if they still have old 19th century physical sciences laboratory tools, including this old telescope still around? And would they like somebody to come over and take a look, maybe clean them up and put them to use? But as far as I know, they just sit there collecting dust.
Okay, would that be under the rubric of the new foundation,
Oh, no,
the
not
Doty
really.
Foundation?
That's off the mark for the Doty Research Institute, this project. But on the side of promoting science, yeah, it's part of the remit of the Doty Research Institute. So, and science history. So that part's relevant.
Very good, very good. All right. Eric, did you want to say anything else, or should I wrap it up for us?
Yeah, I just wanted to add my thanks to Robert for coming by and sharing with us this history of not just the heavens, which goes long, but mankind's gaining understanding of it. It's a neat insight that he has. It's cool that there's a lot of stuff done right along here. And also want to remind people to be with us November 16th when we get kind of a tour de force of some of the basics of skeptics and critical thinking from Melanie Tracy King. And also there might be someone who might be open to helping our group, as we could use more people to be on the council and carry out some of our missions. So thanks again to our audience for being here, and we'll hope to catch you next time. Thanks, Robert. And I'll let you the final word to Reva in case you think of anything.
Okay, great. Well, thank you again, Robert, for speaking to us today. Thanks to everyone who attended today. We'll see you in November for our talk with Melanie Tracy King. And this talk has been recorded and will be placed on our YouTube channel, which is the Philadelphia Association for Critical Thinking.